So sodium is a metal which is not happy. It has too much energy. It would like to gain happiness by reacting with water. And you get explosion. I beg your pardon. So we would like to see why sodium, which is a metal, is reactive, but iron, which is a metal, does not explode with water. And then we're going to use what really explains chemistry to chemists. So I want to find out more about sodium. Where is sodium on periodic table? I beg your pardon. It's on element number 11. How many electrons in sodium? 11. Now remember last time, we said if we want to understand why certain properties is shown by certain elements, we have to look at their atoms. And when we look at the atoms, we said if we want to understand chemistry, we have to look at electrons. So what is special about having number of 12 protons, which means 12 electrons as well, which makes sodium a reactive metal? In fact, if you take a chunk of sodium metal and drop it in a river, you're going to a big fire and explosion. So this is another chemical reaction. When you're adding the metal sodium, and you add this to chlorine, the reaction is going to release a lot of heat and then makes a new compound which is called NaCl, sodium chloride, the table salt. So again, sodium shows reactivity toward chlorine. So chlorine is a non-metal, it's reactive as well. You want to understand why these two love to react together, why these two would like to make a bond. So if I go to next slide, sodium is an explosive metal, highly reactive. Chlorine is a toxic non-metal. You know, chlorine can kill. That's how we sterilize and do disinfection using chlorine. Chlorine can kill us, too much chlorine. That means sodium and chlorine are both reactive. What makes these two reactive? And once these two reactive elements react together, they make table salt, which is needed for life. The table salt is neither toxic like chlorine, and nor it is going to catch fire like sodium. So these two are reacting together, making a compound which is needed for life. Another word, substances, when they react together, they make a compound. The properties of the compound is totally different from the properties of the original elements. So what is happening in the process of reacting together, which changes the properties of substances after reaction? So again, we said the secret of reactivity lies in electron structure. Chemistry is about reactions of electrons. So we said noble gases are very stable. Neon is a noble gas. It's stable. It doesn't want to react. How many electrons in the outer shell? Well, outer shell has 8 electrons. So we come up with this conclusion when we look at noble gases. The fact that having 8 electrons is in the outer shell, having 8 electrons in the outer shell is number of happiness. Having 8 electrons in the outer shell is number of happiness. So this happiness, this stability is called Octet Rule. Octet Rule says.
Question really fast.
Yes, dear, go ahead.
Does the Octet Rule specifically apply to the second shell, or is it any?
No, any substance which has got 8 electrons, doesn't matter which shell, is going to be stable. Now, second shell is a shell which can have 8 electrons, maximum 8 electrons. So the next rule is that if any element has completed outer shell, it's going to be stable in addition to Octet Rule. So do you see that neon has got 2 shells, outer shell, shell number 2, second shell can only accommodate 8 electrons, it has completed outer shell, it's more stable. But relating to your question, helium is also a noble gas. It's not reactive. It's made in sun by nuclear reaction of hydrogen isotopes. And helium doesn't have 8 electrons in the outer shell. It has got 2 electrons in the outer shell. But helium has only 1 shell. And that shell is first shell. First shell cannot have 8 electrons. So this also follows the rule of having completed outer shell. So Octet Rule means having 8 electrons in the outmost shell, bring a stability. Completed outer shell brings the stability as well. As you see, helium has got 2 electrons. However, it has the stability of noble gases. Did I answer your question?
Yes, thank you.
Kerry, that was a great question. Thank you.
I have a question too.
Sir, go ahead, Brendan.
So for like the D and the F orbitals, will
Yes.
those be stable when they're full, or will they still want to go toward having an octet?
Well, no, they look at the completed outer shell, and I'm going to show you a third rule of stability is to have completed half shells. That means if you have the outer shell and each orbital has got 1 electron, is more stable than when one of the orbitals is empty and you have paired electrons. And I'm going to explain that later. So that means just like us, well, happiness has different meaning. Some people like to have a lot of money to be happy. Some people would like to be married to be happy. Some people like to be single. Some people like to spend their life in, let's say, mountains and be happy. So different criteria. Yes, when we look at D and F, I'm going to discuss another rule of happiness and stability. We will discuss that. Thank you. Good job, Brendan. Good question. Anybody else? So guys, if I look at lithium, is lithium stable or not? You look at outer shell, it has 1 electron. It doesn't qualify for any of these 2 rules. It's not stable. Lithium, very reactive. It behaves like sodium. It reacts violently with water, with carbon dioxide, and many other substances, reacts with non-metals to make salt, just like sodium. So Again, one of the rules of stability which makes substances to react together is to get the stability of Octet rule. So Octet rule, one of the rules which makes substances to react together. Neon has 8 electrons in the outer shell, it is stable. Argon has 8 electrons in the outer shell, it's stable. Krypton has 8 electrons in the outmost shell. These are all stable because of Octet rule. They are not reactive. They are happy as they are. In fact, if you ask any element in periodic table, what would you like to do when you grow up? It's going to tell you that I would like to be looking like one of those noble gases. That means they would like to have 8 electrons in the outer shell. So now I want to look at the reason that sodium is a reactive metal. So guys, if you look at number of electrons in sodium, this is 11. So you say, this is the nucleus. All the protons are 2 electrons on first shell maximum, maximum of 8 on the third shell, on the second shell, and left for 1 electron in the outmost shell. So the outer shell doesn't have 8 electrons. It doesn't have complete octet. And it's going to look, sodium would love to look like neon. Neon is the first noble gas, which is closest by number of electrons. How many electrons in neon? Would you check your book? The table inside your book. Tell me number of electrons in neon.
10.
Excellent, thank you, 10. So sodium looks at its closest neighbor of noble gas, which has 10 electrons. It says, I wish somehow I could lose this 1 electron and be happy. Then I would look like, as far as the electron structure is concerned, I'm going to look like neon. I'll be happy. I won't be reactive. And guys, chlorine has got 17 electrons, so you have got 2 on the first shell, 8 on the second shell, and 7 in the outmost shell. So guys, can anybody tell me the noble gas closest to chlorine, as far as number of electrons are, is what noble gas? Closest. Yes, thank you so much. Great job, guys. How many electrons? 18?
Yeah, 18.
So chlorine says, I have only 7 electrons. I need 1 electron to have 8 electrons in the outmost shell. I would follow Octet rule. I'm also going to look like argon. I'll be happy. That's why chlorine is killing bacteria. That's why bleach is going to destroy if you have any stain on the clothing. That's why we add chlorine to water to cause disinfection. So chlorine is going to say, sodium, you know how you have this electron which is bugging you. Why don't you give that to me? I'll be happy. I look like argon and you are going to look like neon. You are both noble gases. We have happiness. So when they see together, did you see the amount of the heat which was coming out of the round bottom flask that I showed you, reaction of chlorine and sodium? That's heat of happiness and excitement, energy released, stability gained. So sodium is going to lose its electron. It's going to look like neon. It has only 10 electrons. You see, first shell has got 2, second shell has got 8. And then chlorine is going to gain that electron. Now chlorine has complete octet, 8 electrons in the outmost shell, and it resembles, as far as the electron shells are concerned, as far as number of electrons are concerned, this chlorine is now a very happy and stable chlorine. Why? It has the stability of octet rule. Sodium is happy. Why? It has got 8 electrons in the outer shell. So both of these have 8 electrons in the outer shell. That means happiness.
I have a question.
Yes, yeah.
Is it stable because there's 8, even though that outer shell can hold 10?
The second outer shell can hold 8 only, and the third outer shell can hold 18.
Oh, 18. Okay.
That's right. Yes.
So
and how would you know that? Do you want me to give you a formula to know how many electrons you can accommodate in each shell? That take the shell number. So if I want to look at shell number 3, square it and times 2. So the formula is 2 and 2 for every shell. N is shell number. So first shell, 2 times the square of 1 is 2. Second shell is 2 times the square of 2, which is 8. Third shell is 2 times the square of 3, which is 18. Yes, we said completed outer shell is one of the conditions of a stability, but having 8 electrons in the outer shell is another. So chlorine now qualifies for complete octet. We're having an octet. So guys, can I say, did we say sodium has got 11 electrons? Sodium has got 11 electrons. And did we say every electron has 1 negative charge? So can I say total charges of 11 electrons is minus 11? And we said in elements, number of protons are the same as electrons because they haven't reacted, they have 0 charge. So plus 11 from 11 protons. So what's total charge of sodium atom before reaction? Is it 0? How about this sodium? This sodium on the other side, it has 1 less electron. It lost 1 electron, right? So can I say it only has 10 electrons? And number of protons did not change. So 10 electrons is minus 10. 11 protons is plus 11. Can I say after losing 1 electron, sodium now has plus 1 charge? Yes or no? Does it make sense?
Yes.
Before
Yeah.
reaction, charge is 0. After reaction, charge is plus 1. How about chlorine before reaction? How many electrons? 17. The charge of 17 electron is minus 17. How many protons? The same number. Plus 17 for 17 protons. Overall charge of the element. Overall charge of chlorine atom is 0. But now in here, can I say it has gained 1 electron? So can I say after reaction, chlorine has 18 electrons, yes?
Yeah.
Minus 18. How many protons? Protons are not changed. So plus 17. Can I say after reaction, chlorine has got 1 negative charge, yes?
Yeah.
Great. So guys, can I say, do we know that opposite attract? Is there any attraction between positive and negative charge? Yes, they love each other. Do you stick together? They bond together. Don't you bond with somebody that you love? We call this bond ionic bond. So can I define ionic bond result of electron exchange between two atoms? Why do they react? They love each other. Why do they love each other? They make each other happy. Ionic bond is like a bond in a very happy marriage. Or happy partnership, whatever you like, whichever you like.